Welcome back to another deep dive. Today we are opening up the hood on a topic that, usually sits quietly in the background of our digital lives, but is arguably the most critical engine for the future of business intelligence.
Okay.
We're talking about retrieval-augmented generation or BARED, as everyone calls it.
It sounds super technical, and I guess it is, but it's really just the mechanism for how we make AI useful in the real world. It's how we bridge the gap between a model that knows general English, like, how to write a poem or code in Python, and a model that knows your specific secrets, your company's data, or your personal notes.
Exactly. But we aren't just doing a generic overview today. We have a very specific target. We're looking at a brand new methodology called ArchRAG.
Right.
And the reason we are looking at it is because the current standard, the way most companies are trying to build these AI brains right now is, well, it's facing a bit of a crisis.
Crisis is a strong word, but I think in terms of unit economics and scalability, it's pretty accurate. We're seeing costs just spiral and accuracy, it's kind of plateauing. We've sort of hit a wall with the current tools.
So to set the stage for you, the listener, I want you to imagine you are back in university.
Okay.
It's finals week, the stakes are high, and the professor announces that the final exam is open book.
Which is usually a trap. Every student knows that open book means impossibly hard.
It is absolutely a trap, because the professor then drops a 10,000-page textbook on your desk. But here's the kicker. The pages are not in order.
Oh, no.
There's no index. There is no table of contents. And to make matters worse, some of the pages are like glued together in these random clumps.
That is a nightmare scenario. So you spend the entire exam time just trying to find the right chapter, let alone the actual answer.
That is essentially what a standard ArchRAG system faces when you ask it a complex question about a massive database. It has access to the information, technically.
Sure, the book is on the desk.
The book is on the desk. But the retrieval process is chaotic. It's frantic.
And to extend that analogy, the current state-of-the-art solution, something called GraphRAG, which uses knowledge graphs, tries to fix this, but its solution is often to read every single page of that messed-up textbook to find the answer.
The brute force approach.
The brute force approach. It works, sure, but it takes forever, and in the world of computing where you pay for every word the AI reads, it costs an absolute fortune.
Which brings us to ArchRAG. The paper we're covering today is titled ArchRAG, Attributed Community-Based Hierarchical Retrieval-Augmented Generation.
It is a mouthful.
It is, but every single word in that title matters. This isn't just a small tweak. It's a proposal to fundamentally restructure the library itself.
That's a great way to put it.
So we're going to break this down into 3 specific acts today. We're going to look at the architect, how ArchRAG builds a better map of the data. Then the librarian, how it indexes that map for speed. And finally, the detective, how it actually retrieves the answer when you ask a question.
And I just have to say, the claims in this paper are bold. We're talking about maintaining and even improving accuracy while reducing the cost of running these queries by hundreds of times.
Hundreds, not percent, times. That's the hook. But before we get to the solution, we have to respect the problem. Let's talk about the status quo. What are we dealing with right now?
So most advanced systems right now use knowledge graphs.
Right.
And standard RG is basically a keyword search. You type in Apple, it finds documents with the word Apple. Knowledge graphs are supposed to be smarter. They map relationships. So Apple is connected to iPhone. iPhone is connected to Tim Cook. It turns your data into this web of nodes and edges.
Okay, so that sounds superior on its face. It connects the dots. So where does it fall apart? Why do we even need a new architecture?
It falls apart in 2 major places, structure and cost. Let's look at structure first. The current industry standard, which is often called GraphRAG, uses an algorithm called Leiden.
The Leiden algorithm. Okay, and this is for community detection, right? Grouping parts of that web together.
Exactly. It's supposed to find the little clusters of conversation. It groups nodes, these pieces of data, based on structural density. Essentially, if a bunch of dots are very tightly connected to each other with lots of lines, Leiden says, this is a community, and it draws a circle around them.
That seems logical, doesn't it? If things are linked, they probably belong together.
It is logical for a graph, but not necessarily for meaning. And this is the critical distinction. Here's the analogy I like to use to explain why this fails. Imagine a massive cocktail party with 1,000 people.
Okay.
You're the algorithm. Your job is to group people into conversation circles.
Got it. I'm looking at the room. It's crowded.
The Leiden algorithm looks at who is standing next to whom. It literally just looks at physical proximity. So if I'm standing next to you and you're standing next to a plumber, and the plumber is standing next to an astronaut, The algorithm draws a circle around the four of us and says, this is the plumber, astronaut, podcaster group.
It groups us by physical structure, just
Kind of
because we
nuts.
happen to be in the same corner of the room.
Oh. Correct. But it doesn't listen to what we're actually saying. I might be talking about AI architecture. The plumber is talking about PVC pipe durability. The astronaut is talking about zero-gravity fluid dynamics. We are structurally close. Maybe we all just reached for the same canapé, but semantically, we are total strangers.
I see. So when the AI then tries to summarize this community, it gets a total mess.
Precisely. It produces a summary that says, this group discusses AI, pipes, and space. It's what the researchers in this paper call low community quality. It's just noise. It creates a completely disjointed narrative that confuses the model later on when it tries to answer a question.
And that's the Leiden limitation. It ignores the attributes, the actual content of the nodes. It values the link over the thought.
Exactly. Now combine that structural problem with the second, even bigger problem, cost.
Okay.
Because these communities are so messy and hard to navigate, standard GraphRAG often has to rely on something called global search.
Define that for us. What is global search?
Global search is the brute force method. It's the panic button. If you ask a broad question like, what are the main themes in this data set? The system doesn't know where to look because the map is a mess.
The index is useless.
The index is useless. So it sends a query to every single community in the graph. It basically forces the AI to read and summarize every single conversation at the cocktail party just to be safe.
That sounds incredibly resource intensive, like unbelievably so.
It's disastrous for the budget. The authors of the ArchRAG paper ran a benchmark to prove this point. They used a standard data set and asked just 100 questions using this global search method.
100 questions, that's nothing. That's 10 minutes of traffic for a small customer support chatbot.
To answer those 100 questions, the system consumed 106 million tokens.
Wait. Let's pause and break that down in actual dollars, because tokens are how we pay for AI.
Right. So depending on the model you use, let's assume a standard high-performance model like GPT-4o or a Claude 3 equivalent, that's roughly $650.
$650 for 100 questions.
For 100 questions. That is $6.50 per answer.
That is completely, utterly non-viable. You can't run a business on that. Hey, ask our chatbot a question. It'll cost us the price of a fancy sandwich.
You'd be bankrupt by lunch. It just doesn't scale. And there's one more issue that's a bit more subtle. Granularity.
Okay.
Current systems are usually what I'd call one-trick ponies. They're either set up to answer the big abstract questions, what is the overall theme of this book, or the very specific ones, who is the main character?
Right, macro or micro.
Exactly. They really struggle to do both simultaneously and efficiently with one single system. They just don't have a structure that connects the big picture to the tiny details in a navigable way.
So to sum up the problem space, we have a system that groups things poorly because it ignores meaning.
Right. The cocktail party problem.
It costs a fortune to run because it has to read everything to find an answer.
The $650 chatbot question.
And it can't handle zooming in and out between big ideas and small facts.
That is the problem space. It is a very expensive, very messy library.
Enter ArchRAG. The paper defines this as attributed community-based hierarchical RAG. We are going to dedicate the bulk of this deep dive to the methodology because this is where the real innovation lives. Let's start with phase 1, the offline build. This is what you called the architect.
Right. This is where the magic starts. Before we can answer any questions, we have to build a house. The first step is constructing the knowledge graph. But ArchRAG does it with a really important twist right at the beginning. It starts by taking your documents and chopping them into chunks.
Standard practice.
Standard practice.
Yeah.
Then it uses a large language model, an LLM, to extract entities and relations.
This also sounds pretty standard, though. Extracting nouns and verbs, finding the people, the places, the things.
It is, but ArchRAG adds a crucial cleaning step right at the foundation. It performs something called entity disambiguation and merging.
Okay, explain that. Why is that necessary?
Well, think about a long document, like a novel or a series of business reports. In Chapter 1, you might see a character named Alice. In Chapter 2, she's referred to as Mrs. Smith. In Chapter 3, maybe she's just the CEO.
Right.
A dumb system, or a basic graph builder, treats these as 3 different people. It literally creates 3 different nodes in the graph.
So you have a fragmented profile of a single person.
Exactly. You get this messy, duplicated graph. ArchRAG uses the LLM to analyze these. It has enough context to realize, wait a second, based on the narrative, these are all Alice Smith. It then merges them into one single robust node that contains all the information about her.
So it cleans up the noise before we even start building connections. It creates a clean list of characters, so to speak.
A clean cast of characters. Yes.
Now, how does the architect solve that cocktail party problem? How do we fix the Leiden limitation?
This is the attributed part of the name. It is the core pivot of the entire paper. Instead of just looking at structure, who is standing next to whom ArchRAG looks at attributes, it actually reads the content of the nodes.
It effectively listens to the conversations at the party.
Exactly. It performs a process the authors call graph augmentation. It calculates the semantic similarity between all the nodes. So let's go back to our party. The plumber is on the left side of the room. The electrician is on the far right side. Structurally, they are miles apart.
Okay.
But ArchRAG listens to them. It reads the attributes of what they're saying.
And it hears things like types and wiring and fixtures, but it understands the underlying theme is home infrastructure or trade skills.
Yes, even though they are structurally distant,
Yeah.
ArchRAG realizes they are semantically very close. So it draws a new invisible line between them. It augments the graph with these powerful semantic links.
It's creating a thematic layer on top of the physical layer. It's basically saying, I don't care where you are standing, I care what you are about.
Yes. And then it uses something called weighted clustering. This is the mathematical part of the architect. It groups entities based on a combined score. It looks at their original structural links. Are they neighbors? But it heavily weights their new semantic similarity links.
So when it draws those community circles now,
The communities are actually coherent. The home repair group now actually contains the plumber and the electrician, regardless of where they were standing. And the astronaut, who was standing next to the plumber, is moved over to the science group where he belongs.
that just makes so much intuitive sense. You organize by topic, not by physical proximity.
And once a community is formed, the LLM writes a summary of it. This group is about home repair. But here is where it gets really clever. This is the hierarchical part of ArchRAG. It doesn't stop there. It builds a tree.
Visualize this for us, because tree in computer science usually means it's upside down, right? The roots are at the top.
Yeah, that's true. Let's use a pyramid analogy instead. I think it's easier to picture.
Okay, a pyramid.
So level 0 is the bottom, the widest part. These are the individual entities.
Yeah.
The specific facts. A leaky faucet in the kitchen, a frayed copper wire, the specific date of a quarterly meeting, all the tiny details.
Okay, the raw data, the individual bricks.
Right. Then level 1 is built from the communities we just made. So you have the
Yeah.
home repair group, the financial reporting group, the marketing strategy group. The system takes each of those entire groups, has an LLM summarize it, and then treats that summary as a single node in the next layer up.
So level 2 groups the groups. It looks at the summaries and clusters them.
Exactly. It repeats the exact same clustering process on the summaries from level 1. So maybe home repair and interior design from level 1 get grouped together into a housing super community at level 2.
And then level 3 might group housing and commercial real estate into a single concept like property.
You've got it. So as you go up the pyramid, the concepts get broader and more abstract. As you go down, they get more specific and granular.
And because this was all built using semantic attributes, because we started by grouping by meaning, every single level of that pyramid is thematically consistent. It's not just random clumps of data. It's an organized, multi-level filing cabinet.
That's the output of the architect phase. A clean, semantically coherent, hierarchical map of your knowledge.
So the architect has done its job. We have a beautifully organized hierarchical library. But a library is useless if you can't find the book you need. We need the librarian.
This brings us to phase 2 of the methodology, the indexing. The paper calls this the CHNSW index.
CHNSW. Okay, that sounds like a secret government agency. Let's break down that acronym.
It stands for Community-Based Hierarchical Navigable Small World.
Okay, navigable small world. I've heard this term in network theory. It's the 6 degrees of Kevin Bacon idea, right? The concept that you can get from any point to any other point in just a few hops.
Spot on. The small world theory is a fundamental concept in graphs. And HNSW is a standard, very fast algorithm for navigating that kind of data structure. But the key modification ArchRAG makes is to make it community-based and hierarchical.
How does that change the navigation? How does the librarian actually use this special index?
So let's go back to our skyscraper or pyramid analogy. The standard HNSW is like having a basic floor plan. ArchRAG's CHNSW gives us 2 very specific and powerful ways to move through the building to find information. First, you have intralayer links.
Intra meaning within the same layer.
Right. Think of these as horizontal hallways. If I am on the 4th floor in the physics department, there's a direct hallway to the chemistry department. The system explicitly links communities that are semantically related on the same level of abstraction.
Okay. That helps if I'm kind of browsing related topics. Like I'm looking for science stuff, but usually I need to dig deep. I'm starting broad and I need to find a specific fact.
And that's the second type, and it's the most critical one. Interlayer links, the vertical connections. This is the high-speed elevator system of the skyscraper.
Okay.
And this is so important. Every broad concept at a high level is explicitly linked to its nearest neighbor on the level directly below it.
So the big housing node at level 2 has a direct cable, a direct elevator down to the home repair node at level 1.
And that home repair node has a direct elevator down to the leaky faucet entity at level 0.
Why is this explicit linking so important? I mean, why does the methodology emphasize this specific part of the index?
Because it physically bakes the solution to the granularity problem into the data structure itself. Most systems keep their summaries completely separate from the raw text. If you find a good summary, you then have to run a totally separate search to find the details that made up that summary.
It's a two-step process.
Right. ArchRAG weaves them together. You can literally slide down the pole from the big idea to the specific fact instantly. The path is pre-built.
Okay, so we have the building, we have the maps, and we have the elevators. The whole structure is built and indexed. Now, it's showtime. This is the detective. Phase 3, online retrieval. This is where I, the user, actually type in a question.
Let's use a practical prompt. Something like, how does a leaky faucet affect my annual household budget?
Good practical question. What happens first inside the machine?
The system takes your question and turns it into a query vector. It just translates your English into a series of numbers, a coordinate in this multi-dimensional knowledge space.
Yeah.
Then it enters the skyscraper.
Where does it start? Does it check the basement, the raw data?
No, and this is the absolute key to the efficiency we see later. It starts at the roof. The very top layer of the pyramid, it uses a top-down greedy traversal algorithm.
Okay, greedy in computer science usually means it just takes the best-looking option right in front of it, right? It doesn't overthink 5 moves ahead.
Exactly. It's fast and efficient. It looks at those massive state-level concepts at the top of the pyramid and asks, which one of you looks most like budget and faucets and households?
It finds the property node or maybe the housing node.
Right.
Duh.
Now, in a standard system or a global search system, it might stop there, or it might start a brand new blind search on the next floor down. ArchRAG does something much more clever. It uses the answer from the top layer as the entry point for the search on the next layer.
So it gets off the elevator exactly where it needs to be. It doesn't have to wander down the whole hallway looking for the right door.
Yes. It takes that inner layer link, that pre-built elevator, down to the home repair neighborhood on level 1. It doesn't have to search the interior design neighborhood or any other part of that floor. It knows exactly which community to inspect. It drastically reduces the search space at each level.
And it just keeps doing this, hopping down the elevator shaft until it hits the bottom, the individual facts.
It does. But here is a really important nuance, and this is where the methodology gets very sophisticated. It doesn't just grab the final fact at the bottom and leave. It collects relevant information from every layer as it descends.
Why, if I'm asking about the faucet, why do I care about the information from the high-level housing layer?
Because context is everything for a good answer. The bottom layer, level 0, tells you a leaky faucet wastes 3,000 gallons per year, a very specific fact.
Okay.
The middle layer, level 1, might tell you water utility rates in this region are projected to rise by 15%. Important context. And the top layer, level 2, might provide the big picture. Proactive home maintenance is a key factor in long-term financial savings.
Ah, I see. So to give a really good comprehensive answer, you need the forest and the trees.
You need the forest and the trees. So ArchRAG collects these attributed communities, ACs, and entities all the way down. It's building a complete dossier on the topic.
It grabs the big picture and the nitty-gritty details simultaneously.
Exactly.
But wait. Now the detective has a huge bag full of clues. Some are these broad, sweeping summaries. Some are tiny, specific details. This raises a big concern for me. We've all heard of the lost-in-the-middle phenomenon with LLMs.
Right. It's a very well-documented weakness. If you just dump too much information into a prompt, say 50 pages of context, the LLM tends to pay most attention to the information at the very beginning and the very end.
And it forgets or ignores the stuff in the middle.
It gets overwhelmed by the noise. The signal gets lost.
So if ArchRAG is grabbing clues from every floor of the building on its way down, aren't we just risking that exact overload? Aren't we just recreating the messy textbook problem at the last second?
We are. And that is a fantastic question because it leads directly to phase 4. This is the final crucial step. The paper calls this adaptive filtering.
Adaptive filtering. Okay, how does this work? What's the final trick?
This is where ArchRAG changed the role of the LLM in the process. Usually, RG systems treat the LLM as just a writer. Here is a bunch of text, now write an answer from it. ArchRAG treats the LLM as an analyst first.
Explain that difference. Analyst versus writer.
Before it even tries to answer your question about the faucet, the system feeds that whole bag of clues, all the retrieved chunks from all the levels to the LLM with the different instruction. It says, don't answer yet. First, I want you to analyze these clues. I want you to grade them. Score each one from 0 to 100 on how relevant it is to the user's original query.
Oh, that's incredibly smart. It forces a quality check before writing. It's asking the AI to audit its own findings.
It generates a relevant score for every piece of context. Then, it performs a simple but powerful filter. It throws away all the low-scoring noise, the stuff that the search algorithm found, but isn't actually useful for the answer. It keeps only the high-scoring insights.
It filters the water before it tries to bottle it.
Perfectly put. And it merges those high-quality chunks. So the final prompt that goes to the writer part of the LLM brain is clean, concise, and highly, highly relevant.
It creates a curated dossier, not a random dump of documents.
Oh. Precisely. This massive reduction in noise at the final stage is what allows it to be so accurate. And it completely solves the lost in the middle problem by deleting the middle. The middle is irrelevant.
This feels like a very rigorous end-to-end process. You construct the graph, you clean it, you cluster by meaning, you build the hierarchy, you index it with elevators, you search top-down, you filter the results, and then you answer.
It is rigorous. And that rigor is designed to solve the specific messiness and noise of real-world data. It makes this core assumption that data is naturally noisy and that meaning is the only truly reliable way to organize it.
Let's talk about those results then. We've walked through the whole theory, the architect, the librarian, the detective, the analyst. Does it actually work? How does it stack up against GraphRAG, the current champion?
The results are, well, they're staggering, particularly on the efficiency side. But let's look at accuracy first. They tested this on standard academic benchmarks like Hotpot QA and multi-hop RAG.
And these are data sets designed to be really difficult, right? Multi-hop implies you have to jump between different facts to get the final answer.
Exactly. A multi-hop question is something like, who is the wife of the actor who starred in the movie directed by Christopher Nolan in 2010? You can't just Google one keyword. You have to hop from director, movie hack, actor, wife.
That requires a really, really good map of the data.
It does. And ArchRAG consistently outperformed the baselines. On some of the specific metrics, it achieved about 10% higher accuracy than the existing state-of-the-art methods.
In the AI world, a 10% jump on a mature benchmark that's significant. Usually researchers are fighting for fractions of a percent.
It is. It's a solid win. Yeah. But honestly, the accuracy isn't the headline for me. It's a great result. But the real headline is the token usage, the cost.
Okay, remind us of that horror story number from the beginning, the $650 lunch bill.
Right. The standard GraphRAG system, using that brute force global search, used 106 million tokens for 100 questions, about $650.
And ArchRAG, using its top-down hierarchical search.
ArchRAG reduced token usage by up to 250 times.
250 times, not percent.
Times. So instead of 106 million tokens, we are talking about maybe 400,000 tokens. Instead of $650, we are talking about $2.50.
That completely changes the economics of the entire field. That moves this technology from a cool R&D project to a product we can actually ship to customers.
It makes high-level, context-aware RAG commercially viable. You can actually afford to have an AI that understands the big picture because you aren't paying it to read the entire library every single time you ask it a question.
And what about speed? I have to assume if it's reading that much less, it's also faster.
Oh, much faster. The paper reports that the hierarchical search is up to 5.4 times faster than standard baseline searches.
It's almost intuitive when you lay it all out, isn't it? If you organize your room properly, it's faster to find your keys.
It really is. And it validates the entire attributed community approach. By taking the time to group things by meaning rather than just by structure, you create a map that perfectly matches how users actually think and ask questions.
I want to circle back to something we touched on earlier, this distinction between structure and attributes. This seems to be the core philosophical divide in this space. Why do you think previous models focused so much on structure and ignored the attributes? Why was everyone just looking at the links?
That's a great question. I think it's because links are mathematically clean and simple. A graph is just nodes and edges. It's binary. You are either connected or you aren't. And for decades, computer scientists have loved that kind of purity.
It's easy to calculate. It's predictable.
Right. Attributes, the actual meaning of a chunk of text, is messy. It's subjective. It's fuzzy and hard to quantify. What does home repair actually mean in a mathematical sense? It's difficult.
But LLMs are really good at the messy, fuzzy stuff. That's their whole thing.
Exactly. And that's the paradigm shift that this paper represents. Previous methods used older algorithms like Leiden that predate the modern LLM revolution. ArchRAG comes along and says, hey, we have this incredible new tool, this super brain LLM. Let's use it to organize the data, not just to read it at the end.
So it's using the AI to build the library, not just to act as the librarian who reads the books.
That's a perfect way to put it. It uses the LLM to augment the graph, to draw those new semantic lines between the plumber and the electrician before the user's search even begins. It's about introducing understanding directly into the structure.
Now, I have to play devil's advocate for a second here. We need to check the assumptions the authors are making. This whole system seems to rely very heavily on that summarization step.
Right.
When the LLM summarizes the home repair community at level 1 to build the node for level 2, if it does a bad job, if it hallucinates a detail or misses a key concept, does the whole pyramid collapse?
That is the primary risk factor. That is the assumption check you have to make. The entire system is dependent on the quality of those hierarchical summaries. If the summary of the home repair community fails to mention the concept of plumbing, then when a user asks about a leaky faucet, the top-down search might never decide to go down that elevator shaft. It might skip that whole floor entirely.
So the librarian, or the architect rather, needs to be a really good writer.
Yes, absolutely. However, the paper argues, and I think it's a strong argument, that because they clean the entities first, and because they group by semantic similarity, the clusters are naturally much more coherent to begin with. It is much, much easier for an LLM to accurately summarize a room full of plumbers than it is to summarize a room full of random strangers standing next to each other.
I see. A coherent group leads to a coherent summary. The quality of the input dictates the quality of the output.
Exactly. Garbage in, garbage out. But in this case, it's clean in, clean out. By fixing the grouping problem with attributes at the very beginning, they make the summarization problem much, much easier to solve reliably.
I also want to just touch on that granularity issue one last time. We said that most systems are bad at doing both abstract and specific queries. How confident are we that ArchRAG really solves this?
The confidence comes directly from that multi-layer retrieval strategy, because it deliberately pulls data from the city level, the neighborhood level, and the individual house level. It inherently covers all bases.
Okay.
If the user's question is abstract, the most relevant information will likely come from the top layers. If the question is specific, the answer will be found in the bottom layers. The adaptive filtering step at the end is what decides which one is most relevant for the final answer.
So it doesn't force the user to specify, I want a broad answer or I want a specific answer. It just grabs everything potentially relevant and then filters for the best fit.
Right. It adapts to the granularity of the question rather than forcing the system into one mode or another.
So zooming out, we have a system that seems to mimic human memory organization. It groups things by concept. It uses a hierarchy of abstraction. It filters out noise before making a conclusion. Is this the new standard?
I think it certainly points the way. The reduction in token cost alone makes it very hard to argue against. But I think the real long-term legacy of this paper will be the popularization of the hierarchical brain for AI.
What do you mean by that, a hierarchical brain?
We're moving away from this idea of flat retrieval, where every document in a database is treated as equal to structured retrieval. We are finally building memory architectures for AI that look a lot more like how humans organize information. When you think about the concept of Europe, you don't instantly recall every single street name in Paris.
No, of course not.
You access the high-level concept of Europe, then you might drill down to France and then to Paris and only then to a specific street if you need to.
And you only zoom in when the query requires it.
ArchRAG is teaching AI to do the same thing. It's all about cognitive efficiency. It's treating a massive corpus of data not as a flat, undifferentiated lake, but as a deeply structured, navigable library.
We've unpacked a whole lot here. The architect, the index, the search, the filter. It's a really impressive piece of engineering.
It's a huge leap forward in making ArchRAG practical and scalable. It feels like it solves the cost problem, the noise problem, and the structure problem all at once.
I want to leave the listener with a thought here as we wrap up. We often worry about AI hallucinating or getting confused, but systems like ArchRAG suggest that the solution isn't necessarily just a bigger, smarter model. Sometimes it's just a better organized library.
A better filing system can make an average employee look like an absolute genius. The same principle applies to AI. If you give it a clean map, it can find the treasure every time.
And here's a provocative thought to close on. The authors of this paper note that they use the LLM to clean the data, organize the data, summarize the data, and filter the final answer. We are rapidly approaching a point where the AI isn't just learning from our data, it is actively rewriting and restructuring our data into a format that it understands better than we do.
That's a slightly unsettling thought.
Right. If the AI organizes the entire library of human knowledge in a way that is most efficient for its brain, will we eventually need the AI to translate our own knowledge back to us?
We might end up needing a human compatibility layer just to understand our own history. You won't be able to just browse the library anymore because the whole thing is optimized for vector searches, not for human eyes.
On that slightly chilling note, maybe go organize your bookshelves, everyone. Thanks for listening to The Deep Dive.
See you next time.